requirement to have all ground lugs under a single bolt is likely based on the following code sections. NEC Article 250.120 states the grounding electrode conductor or grounding electrode shall be connected to the grounding electrode system by means of a single connection. NEC Article 250.60 states a terminal or bus identified for the connection of the grounding electrode conductor shall not be used for any other purpose. The reason for requiring a single bolted connection for ground lugs is to ensure a reliable grounding path. Connecting multiple ground lugs to a single bolt creates a single point of failure if the bolt loosens or fails. A single, properly torqued bolt provides a more secure and reliable connection for the grounding electrode conductor. There is an exception to this requirement for separately derived systems. NEC Article 250.24 fifth states the grounding electrode conductor for separately derived system shall be connected to the grounding electrode system by means of a single connection or by means of multiple connections where each grounding electrode conductor is connected to the grounding bus or buses and to the grounding electrode or electrodes by a single bolt. If the ground lugs are not connected under a single bolt, the following consequences may occur. Firstly, the electrical inspector may fail the inspection. Secondly, the grounding system may not be effective in protecting against electrical shock or fire. Thirdly, the installation may violate local building codes and safety standards. It is strongly recommended to comply with the requirement for single-bolted ground lugs to ensure a safe and reliable electrical installation. Let's delve deeper into the rationale and specific applications of these code requirements. Grounding systems are a critical safety component in electrical installations designed to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices, such as circuit breakers or fuses, to quickly de-energize a faulted circuit, minimizing the risk of electrical shock or fire. The grounding electrode conductor, as defined in the National Electrical Code, or NEC, is the conductor used to connect the system grounded conductor, typically the neutral, or the equipment grounding conductors, to the grounding electrode. The grounding electrode is a conductive rod, plate, or system of interconnected electrodes buried in the earth, providing a connection to ground. Article 250.120 of the NEC emphasizes the importance of a single, robust connection between the grounding electrode conductor and the grounding electrode system. This requirement is in place to minimize the potential for high-resistance connections, which could impede the flow of fault current and compromise the effectiveness of the grounding system. The intention is to create a direct, reliable, and permanent connection that will withstand the rigors of environmental conditions and the stresses of fault currents. Article 250.60 further reinforces this concept by stipulating that a terminal or bus designated for the connection of the grounding electrode conductor must not be used for any other purpose. This provision prevents the overcrowding of grounding terminals and ensures that the grounding electrode conductor has an exclusive and dedicated connection point, free from interference or potential compromise by other conductors or equipment. The single-bolted connection requirement is particularly important in transformer installations, where the transformer acts as a separately derived system. A separately derived system is an electrical system whose power is derived from a source other than a service, such as a transformer, generator, or inverter. In these systems, a grounding electrode conductor is required to connect the separately derived system's grounded conductor to a grounding electrode. The exception provided in NEC Article 250.24 allows for multiple connections in separately derived systems under specific conditions. This exception recognizes that in larger installations, it may be necessary to have multiple grounding electrode conductors for practical reasons or to achieve lower impedance grounding. However, the key stipulation is that each grounding electrode conductor must be connected to the grounding bus or buses and to the grounding electrode or electrodes by a single bolt. This means that while multiple grounding electrode conductors are permitted, each individual conductor must have its own dedicated and secure connection point. The reasoning behind the single-bolted connection requirement is multifaceted. Firstly, it simplifies inspection and maintenance. A single, readily visible connection point allows inspectors and maintenance personnel to quickly verify the integrity of the grounding connection. Secondly, it reduces the risk of accidental disconnection or loosening of the connection. A single, properly torqued bolt provides a more secure and reliable connection than multiple connections that may be subject to vibration, corrosion, or other factors that could compromise their integrity. Thirdly, it minimizes the potential for galvanic corrosion. When dissimilar metals are used in grounding connections, galvanic corrosion can occur, leading to the deterioration of the connection and an increase in resistance. A single, properly selected and installed bolt minimizes the contact between dissimilar metals and reduces the risk of corrosion. Non-compliance with the single bolted connection requirement can have serious consequences. An electrical inspector may fail the inspection, delaying the project and requiring costly rework. More importantly, a compromised grounding system can significantly increase the risk of electrical shock or fire. If a fault occurs and the grounding system is unable to provide a low impedance path for fault current, the overcurrent protective devices may not operate quickly enough, or at all, leading to a dangerous buildup of voltage on exposed metal parts. This voltage can pose a lethal shock hazard to anyone who comes into contact with the energized equipment. Additionally, a high-resistance grounding connection can generate excessive heat, potentially igniting nearby combustible materials and causing a fire. Furthermore, non-compliant installations may violate local building codes and safety standards, resulting in fines, penalties, or even legal action. In order to ensure compliance with single-bolted connection requirement, it is essential to follow these best practices. Firstly, carefully review the NEC and local building codes to understand the specific requirements for grounding electrode conductors and grounding connections in your jurisdiction. Secondly, use only listed and labeled grounding lugs and connectors that are suitable for the application and the types of conductors being connected. Thirdly, ensure that the grounding electrode conductor is properly sized according to the NEC. Table 250.66 provides guidance on the minimum size of grounding electrode conductors, base, and the size of the unrounded service entrance conductors. Fourthly, clean the contact surfaces of the grounding lugs and connectors to remove any dirt, corrosion, or other contaminants that could impede the flow of current. Fifthly, apply an antioxidant compound to the contact surfaces to prevent corrosion and improve conductivity. Sixthly, torque the grounding bolts to the manufacturer's specifications using a calibrated torque wrench. Over-tightening or under-tightening the bolts can compromise the integrity of the connection. Seventhly, visually inspect the grounding connections to ensure that they are properly installed and that there are no loose or damaged components. Eighthly, periodically inspect and maintain the grounding system to ensure that it remains in good working condition. Check for corrosion, loose connections, and any other signs of degradation. If any problems are found, take corrective action immediately. In summary, the single-bolted connection requirement for ground lugs is a critical safety measure that is designed to ensure a reliable and effective grounding system. By understanding the rationale behind this requirement, the applicable code sections, and the potential consequences of non-compliance, you can take steps to ensure that your electrical installations are safe, compliant, and reliable. Always consult with a qualified electrical professional if you have any questions or concerns about grounding requirements or electrical safety.